The old man builds. The old man builds. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds. Shawn, what's going on, brother?
Hey, it's great to be back on the show. I missed you guys, and I'm feeling pretty well. It's 2 weeks in a row. So I appreciate you having me on, and I'm ready when you are.
Dude, I'm going to tell you this right now, Shawn, before we start. Everybody's excited, man. They love the topic that you got on to. Why don't you explain the name real quick, and then we can start your presentation.
Yeah, good point. So basically, if you guys saw my last presentation, I was showing how plasma can be spun in an orderly fashion on the surface of a clay pot. I originally called it a surf burp, but by popular demand, I've changed the name from surf burp to RAV. It is a resonant arc vortex. So a resonant arc vortex, you can call it RAV or RAV. I'll be calling it a RAV throughout this presentation. So thank you for that.
Right on, Shawn. Okay, let's get going, man. Here we go. People are ready. All
Awesome.
you.
Sounds good. Let me find what I'm. Oh boy, we were ready for this too. I apologize. Technical difficulty. 1 second. Let's see. All right. Oh, here we go. Something happened here. Sorry, 1 second. I'm gonna just change this up here. All right. Let's see. Oh, almost there. Go. Let's see. Sorry, guys. Just a couple more seconds, and we should be there. How are we looking, Nathan?
Yeah, we're good to go.
Awesome. Okay, so if you guys remember again from last week, I was spinning plasma balls on a clay pot. I want to first give credit, like I did last week. My inspiration for this experiment was from a book I read 33 years ago. It's by the writer R.A. Ford, and I'll be sharing his book later. But I just want to let you know that I give him credit because 33 years ago, when I read his book, this impression was left on me, and so I decided to kind of make it my own version, like I usually do. And so what you're seeing here is basically a pot that's in a pan of water, and then water is dabbed where the arc here starts. Then I have if you look at the top, I have the anode. So the bottom pot of water is the cathode, the negative. The top bar is an anode. And then when it hits the wet spot on the clay, it starts spinning, and it creates this kind of sphere. Now, this is an exaggerated view of it. As we're going to go through them and talk about them, you'll notice that the bottom here is just way too long. It's normally the bottom is very short and the top is longer, but this is what you're basically going to be seeing. And I put the measurements here, 2 to 3 millimeters. In actuality, I've been able to double and even triple their sizes. So here's another kind of picture of it that I think has made me a little bit easier. Again, it's on the clay though, not in the water. And in the pot, there is no water. So maybe it's a graphics issue. But again, we have an anode coming in. It's a high voltage that runs between 5,000 volts to 30,000 volts. And as I'm able to apply higher voltage, all of a sudden, then this action starts to happen. I just wanted to read a couple theory things, and we'll get into the experiments. So a resonant arc vortex is a high voltage surface bound plasma phenomenon observed in experiments involving a sharp anode and a grounded substrate of clay immersed in water. The RAV, or the RAV, begins as a purple plasma discharge and transitions into a stable white hot vortex connecting the anode and the substrate. Its self-sustaining nature and resonant behavior make it a distinct conventional plasma discharges. And then I just want to say one more thing about what we're looking at here, and it's plasmoid. Plasmoids are self-contained plasma and magnetic field structures like ball lightning and spheromax. I don't know if I'm saying that right. Vortex structures in gas discharge plasmas show coherent motion and can be magnetically confined. And so in my research, I kind of came up with these sort of theory of what's going on here, and then we can talk more about it as we get through. So I'm going to kind of kick the dead horse of the RAV, the RAVs, but I'm hoping that at the end of this short presentation, we can talk about them. And so if you guys remember that the anode, when the picture comes in sharp, and then if you'll see here, the flow of electrons comes down, and then when it hits the clay has moisture in it, as well as the clay itself has iron oxide. Thank you, Jarvis. And what it does is, as it begins to heat up, the steam, the properties of the clay, initiates this sort of spinning ball of plasma. Now, this thing, plasma will sustain if I adjust the voltage. And I've learned how to keep these things running for quite a bit. So we're going to talk more about that. But I kind of wanted to just sort of show you here what's happening, and at a still picture, from a still picture. There's another picture, so I've been able to get them bigger and bigger. My goal is the size of a golf ball. I'm nowhere near that yet, but I'm having some good success. Some of these are going to be a mix of slides that you might have seen last week, and then, of course, new slides. Now, as you see, as the clay is heating up and the water starts to come out, the water works in conjunction with the clay to get that spinning vortex. Now, as the vortex spins, those temperatures are in the millions of degrees in the middle of that white ball, and it's so hot that it etches the clay. So it doesn't burn the clay. There's no smoke. And it also vaporizes the water. And when you think of water vapor, you think of steam. No, this is such a high energized steam, you don't see it. So there's no smoke, there's no water vapor, because they're incinerated in this spinning vortex, the RAV. Now here, I think I shared this last week, but here's the basic construction. Here, if I can get my mouse straight, this is the basic construction of what I have. Now, notice that it's on a metallic surface, okay? That's important. If you see that I just used aluminum tape, you'll want to see that there's a connection over here to the cathode, and there it runs right into the power supply that gives us between 5 and 30,000 volts DC. 10 milliamps or less, so it's not a scary amperage that it can be, but you need to respect it still, because it'll still bite you and it can cause permanent damage. The red here you see from the right, that comes into this very rigid stainless steel wire. This is about 2 millimeters in size. It's very thin. The important characteristic of this is it can't move. So I'm going to show you when I tried thin copper and it didn't work. You need this super rigid, about, let's say 4 meters, half a centimeter from the clay, like a 1/4 inch or a little bit more than a 1/4 inch from the clay. And then you fill this up with water here, and you'll notice at the bottom of the clay pot that it's starting to wick the water, starting to draw the water into itself. That's part of what you want going on here, is because there is a connection between the water vapors that are evaporated here with inside the wicking pot are interacting with the dab of water that I place here with a Q-tip. And then you have the high voltage at the right angle and the right distance, and then boom, you'll start to see a clockwise movement And then as that clockwise movement sets up the environment, then boom, you'll have a RAV. A RAV, just this resonant arc vortex. So in this setup, watch first the top of the screen and watch the oscope. It looks noisy, doesn't look great. And then watch it, boom. Okay, so I'm going to pause it here. So what I did was, if you look at the bottom at the pot, I was initiating the voltage to begin building a RAV. And you noticed earlier that the screen was all chaotic on the oscope. And then when the RAV appeared and the spinning vortex of plasma appeared, you'll see on the screen here this really orderly frequency. It's kind of a cross between a triangle wave and a sawtooth wave. But that spinning ball of plasma, it's obviously self-organized, because this is quite a steady frequency. And this is really representatory of its rate of rotation. And so if my memory serves me correct, it's 106 kilohertz. So what that means is that the RAV is spinning at 106,000 times per second. So that's pretty quick spin frequency. It kind of reminds me of neutron stars. So let me play this thing now again and see if you guys can keep track on both. Let's try this again here. Where is my bar? I don't have a bar. Okay. If you watch down on the pot, it starts to form, and as soon as it hits the RAV, it clears up. There we go. I caught it. So if you look at the bottom there on the clay pot, you'll see that the RAV there is just starting to form, and you can see the signals becoming very distinct and very clear, and becomes more orderly as the RAV begins forming that sphere that's more symmetrical, and it's in full form. Let's see. Let's go to the next one. So this is a real. I can't even speak tonight. Sorry. This is a zoom in on the oscope, and so that's correct. It says it's in the 106 kilohertz range, and this is basically a representation of the rotation of the RAV. So very fascinating. It definitely gives you the sense that it's self-organizing, because I'm just applying a random voltage, just a plain voltage, and it's initiating all these different behaviors. Showing you the setup where I can dial in between 5,000 and 30,000 volts, and it has another channel. There's the aluminum tape on the dish. I've shown you the anode and the cathode as we're getting ready. And this is a kind of an idea of the setup. So if you guys want to do it yourself, this is an old microwave dish, the microwave dish that spins in your microwave. And then that's the rigid stainless steel metal that I used. And this is a clay pot that I bought off of Amazon. Important thing about this pot is, there's a cup of water ready to be poured. The thing about this pot, it's not your average pot. And I wish I could, here we go, wait. No, that's volume, okay. So the pot is square. So because the reason why I found a square pot is because it gives you the most flat surface areas. I did some experiments on curved pots, and they weren't as good. So if one of the keys to getting a real good RAV is to use a square pot that we're going to see here in just a second. You'll see you can order them on Amazon. They're very cheap, maybe $10 for 4. See here, if we can get to the pot, there's the wire. I wish I could scroll, guys. There it is. So this square pot gives you a lot of surfaces that are flat. So that's kind of part of the winning combination if you want to make these at home. So I pour into the dish with my old chewed up ruler here. This is about a millimeter. Actually, I'm sorry, 2 millimeters of water. So roughly, you don't want it to be super thin, but you don't want it to be super thick either. The reason for that is the water is going to wick into the pot faster, and that's not desirable. So again, here I'm kind of showing you the water line. So when it started in the pot, it was only maybe a couple millimeters at the bottom here, but after about an hour later, you can see the water moves up. And so this is kind of representation of what you're going to view. And I'm just going to say it right now, but I'll reiterate it is once this starts climbing up to close to where you're building your ravs, then you won't be able to build any more ravs anymore. So the cure is take it out of the water, let it dry, and put another dry one in here, and you're good to go. And I'm giving you the distance here of the metal. Again, I don't know why I'm using this ruler, but it's about 3 to 4 millimeters away. You can actually go further or closer, but the sweet spot's about between 4 and maybe 5 millimeters max, or half a centimeter. Now, this was my first clay pot. My wife gave it to me, and I took the Dremel tool and cut it in half, and it didn't have a lot of flat surfaces. So when I initiate the voltage here on the surface here, notice how I'm not getting any ravs. I'm just trying to look for that sweet spot, but what I'm getting is this rotation, and this rotation in a circular manner is usually clockwise, which I don't understand why, but that's normal. Is that it goes clockwise. I don't know, maybe if you're in Australia, it goes counterclockwise. I'm not sure. Maybe it corresponds to when you flush your toilets down south or in the north. But notice here too, I'm not getting any ravs because I'm really close to the water. So remember I told you, you can't be too close to the wicked water, or it will just spin in circles and not find the rav. I'll usually, instead of use my finger, I'll dab the water with a Q-tip, and that's going to confine the plasma to the area of that dabbed water. And not sure what I'm doing with my camera here, but there you go. You can see it, and it's not in the clockwise manner because I made the dot really small of water. And because of that, it builds its rav and then it loses its rav as fast as it built it. So don't, it's more of a finesse. Don't try to strong arm it with their highest voltage like I'm trying to do here. Once you find the rav, then just dial it back. And I'll show you how to do that here in a little bit, how I do it. So here's multiple drops of water, maybe 4 or 5. I'm going to hit it with about 30,000 volts. And sorry about that. Since next video here. There we go. It's got its clockwise kind of movement. And once the water hits a certain vaporized state or temperature, look at that. It begins to self-organize into this spinning ball of plasma. Now, what I'm doing here to keep it going is once I go to 30,000 volts and it appears, I then dial it back to 5,000 volts. It's very interesting. So once you start the RAV at 30,000, dial it back and it will stay way longer and it will grow if you give it less voltage. So sounds kind of counterintuitive, so it's a bit tricky for me to learn. But when you see this thing start to develop, I hit it with 30,000 volts. And then once the RAV appears, I jump it, I scroll the potentiometer all the way to 5,000 volts, and it just stays and it grows. So that's a new thing that I found out. Look at that. It's bigger, and it's just smooth as silk. It goes completely silent in the room, and that's because I'm dialing it back to 5,000 volts, and I'm continuing the reaction. This kind of split into 2 RAVs, which is interesting. And we'll look at some of the designs here in the etching. There's no burning, there's only etching and vaporization, just so you know. It's a different phenomenon than burning. Same phenomenon here. soon as the rev appears, I dial it back. This leakage here is because I'm not hitting the right voltage. And believe it or not, interestingly enough, the more voltage, the lower the frequency. So what that means is the lower the wait, did I say, wait, here, the higher the voltage, the lower the frequency. So they're opposites. And so when you're wanting to control the spin of it, voltage controls the frequency of the spin, and they're opposite or inversely proportional. Increase voltage, decrease rotation, decrease voltage, increase the rotation or the frequency. And so you can put that together, that there's some capacitive action going on here, because if you increase capacitance, the frequency goes down. If you decrease capacitance, then the frequency goes up. And when I say frequency, I mean the resonant frequency. These little revs are working or operating physically in their resonant frequency. That's very important. That's why I changed the name to Resonant Arc Vortex, because there's a resonance going on. Now, what you're seeing here is the clay is too wet. Once the water wicks up to a certain point, I can't find any voltage. It just sort of makes this pretty display, but I'm unable to make a rev. So remember that when you're trying to do these yourselves, because if the pot's too wet, you're just going to cover the pot in plasma, and you won't see it self-organize into a rev. And so here's with the lights out, you can kind of get an idea. I'm still not very accurate on controlling the voltage. Another thing you're seeing on the left is the water is wicking, and this means that it's now making it more difficult to create the rev, as you're seeing here. So there's a relationship between keeping the wicking of the water down. Otherwise, you get this very fascinating plasma display, but you won't be able to see it self-organize into a spinning ball. So here I'm going to see if I prove myself wrong and apply the voltage there in the very wet part of the pot. And I'm doing three things at once with my two hands, so forgive the shaking. But I'm trying to get the camera literally touching almost, so you guys can get this really good angle. So my poor phone's getting a beating here. There we go. Here I'm dialing back the voltage to 5,000 volts, and it's just silent. And I'm just managing as best I can. And the only thing really after I get the voltage right is I'm just running out of water. That's it. So when it starts breaking apart here, that means I have no more moisture. There we go. And then there you go. It sort of buzzes out. So I'm lessening the voltage, and then I'm kind of just going back and forth, not to 30,000 volts, but maybe 5 to 10,000 volts to keep it operational. I wanted to share this here because this is a track of one RAV. Okay, here we go. Oof. You'll see that it has one touchdown part here on the right, a large one. Then there's one over here and over here and over here. This was one RAV. So this is another interesting phenomenon of the RAV, is that it'll actually jump in the air, the spinning ball, and it'll land over here. It'll jump in the air, it'll land here, and so on. So this was the RAV needle over here, but it was jumping over here. The reason for that, I've learned in my testing, is that there seems to be denser spots of minerals in the clay, as well as there might have been some moisture that maybe when I was dabbing it got splashed over here. And so therefore it had the right environment. So this is another fascinating behavior, because it actually is a spinning ball in air, and the only thing that's feeding it is the anode. No cathode, okay? It literally is just saying, I know what to do. I'm going to spin in the air until I go and find this little cool spot over here. That's very interesting to me. Right, so don't take your hand and grab the pot and move it when the 30,000 volts is on, because you can get shocked. So I'm just exhibiting what you shouldn't do. that familiar spinning. It might look like it's going in two directions, but actually, it actually is going in the clockwise position. And I just keep applying, wishing the rab to come into play here. Come on. You're probably wondering why I'm showing you this fail, because times this fail times 100, and that's how many times it takes for me to figure all this out. But I had a lot of those, so thought I'd share one. Here, I'm just trying to get you a super close up. And I'm going to be working on different close ups so you guys can kind of see the phenomenon here in action. Get it nice and soaked in. See what this guy can do. I love the sound of it for some reason. I think Lulu pointed out too. There's just something interesting about the sound. Okay, so this was what I wanted to show you, is that there's different heat rings, different evaporation rings, and that's kind of was the purpose of this one, to kind of show you how it sort of clears the water densities within the clay in a very almost a perfect circle, and then it prepares it to create the rav. So I kind of wanted just to stop there so you wouldn't be distracted by the rav, but to kind of show you the first steps before the rav is developed. Here I dab some more water in the same place, and kind of show you now it has those different zones. Look, the water is just nearly evaporated, and then here comes a rav. So there's just sort of mixture. Again, I'm dialing it back. I want this thing just no noise. Should stop talking. Now notice how red hot the clay gets. I'll show you some infrared later, but the red hot clay has a little bit to do with this action. It seems that when the water is vaporized and the clay is vaporized, that's the action that is behind this self-organizing plasma. There's a different angle. It's going to kind of show you different angles, different spots. We'll talk about some failures, some different kinds of failures. This one I probably got about a ½ inch away, maybe a little less than a ½ inch, but it's a decent distance. And I can still create them. There we go. I'm dialing it back to 5,000 volts. It's almost like spinning a top. Once you put on the forward energy, then you can just take your hand off and it'll spin on its own. It feels like that when you take it from 30,000 volts down to 5,000 volts. And by the way, the power supply is very accessible. It costs under $100 on Amazon, so it's not something that would break the bank. There we go. Listen to that. I can listen to that quiet all day. One of the things when it gives you that blue haze, that means that it's wicking the water up. This blue haze means you're not going to be able to make these little ravs after a while. So good to know that. Now the water is wicked up to the top of the pot, and you can see that it's making its big circle. And I was so hopeful because I couldn't imagine how big this rav would be, considering that its diameter of setting up for the rav is so large. This pot is about 5 inches in height. So this is probably a good 3.5 inches here of rotating plasma. And I guess what's fascinating to me too is that rotating plasma, by hitting it on a wet piece of clay, that in itself is fascinating to me. So we're going to get into some different phenomenon now as the clay gets more and more wet, and we'll go through these. If you guys wanted a really detailed analysis on some of this, Old Man Builds, Nathan, he did a show or a live stream with Joe, and Joe and him came up with some really interesting ideas on how to better understand these, and they were just knocking it out of the park with their definitions. So if you look up this on Old Man Build Station, and Nathan and Joe dig in to perform a detailed analysis. And so we're seeing now that the water is wicked. And no matter how hard I try, it's going to be no RAV. But the phenomenon that changes into is still interesting. If I had the oscope running, you would still see some frequencies in here. Um, but there it is with the lights out, so you can kind of see what I'm doing. I have a different shaped anode there. It's a sharpened, thick piece of copper. It's almost like starting an engine. You got to keep pulling the cord on the lawnmower and get these things spinning, and see if you can nail the RAV. And like I said, you guys are going to kind of almost get bored of these after a while, but I really wanted to show you how they're working and what I've learned thus far. Look, it's the death purple haze. Oh, we've got one. Look at that. Woof. Look at that. Beautiful. Notice again how they're bigger. That's me playing with the voltage. Less voltage, bigger RAV. Talk about counterintuitive, but really it's just fighting all of these different forces because there's just water everywhere now, and there's all these different resistances as the clay is conductive, and then it becomes different ohmage values. So if you think about it, the whole surface is like a bunch of variable resistors, and so the plasma here is just trying to find the easiest way to the cathode, and here I'm just stepping it up. 1,000 volts at 1,000 volts at a time, just to kind of show you that when it's fully immersed in the water, when the pot is fully wicked up to water, this is what you get. You get this pretty fascinating set of waveforms. And one of the cool things that Ethan and Joe did, and you'll catch us in the video, is that they stepped. Sorry about that. I don't have a scroll bar for some reason here. They were stepping it through each voltage increase and describing what was going on into it. And I feel bummed that I can't do it now, but I'll just replay it here and you can kind of get the idea of what it's doing. This is wet clay, guys. Nothing fancy. Nothing exotic. In the daylight, there's no RAV here because, again, the pot is wicked up all of the water. Got a kind of a aesthetic beauty to it, doesn't it? It's got its own kind of beauty, artistic quality, I guess, if I'm not trying to toot my horn. It's just the clay and the voltage and the water. And how 99.9% of the universe is created out of plasma. It seems like God loves plasma, and so I love plasma, and it's awesome. And this is DC, so this is, if you guys have seen my other Tesla coils, very different kind of voltage. Notice here that the bottom of the pot, it's actually wet inside. It's actually climbing into the here on the top, and it's just amazing. It puts out all these tendrils looking for the easiest way to get to the cathode, which is the pot, dish of water at the bottom. And yeah, I'm going to kind of zoom out, let you know this is the clay pot action at its best. Almost as bad as a dad joke, but I'm a dad, so all right. This is another close up, and I'm gonna start letting you. They have a singing voice too, a squeal that I learned a little bit later. So, but this was, so I'm just gonna kind of give you some cool RAVs that I created. They're kind of a little bit different in the angle that I'm doing in and the distance, and I'm dialing it in with the 5,000 volts, and look at that, it's just such a clean RAV, and it just smoothly glides over the pot, etching and vaporizing. And a beautiful thing. This one's a little bit further away. And look at that. Just hit it 30,000 volts, boom, dial it back to 5, and just let it dance. This pot was a little dry, so it was a tiny one. Now, this is what I was trying to do here is I was creating two dab marks of water. And my thinking was, is it going to affect the field in a way where it can create the rotating vortex on either side? And it didn't do that. I thought it would, but it didn't. So just trying different dab configurations. And so here I just connected in the middle. Look at that. So all it needed was the dab of water in where I put the needle, and I was going to get a rev, and they just last a long time with my hand on that dial. I'm going to try to figure out how to do this with a kind of feedback. So that way the voltage is controlled by the spin action of this plasma. And I really think then you won't have this noise. You'll just have that RAV in its purest form. And then maybe study how when it goes airborne and jumps to another location, because I think that you're getting closer and closer to sort of a self managed spinning plasma. Maybe almost you could call it a ball lightning, but that's probably a stretch. Here are some of the paths that it leaves. So one of the reasons why I know that it's spinning is that these etches. I did a lot of research. The discolorization and the angles. This is not indicative of an oscillation back and forth. This is indicative of a revolution or rotation, I should say. So rotation, not oscillation, and I proved that also earlier because it has a frequency. An oscillation would be much different than what we're seeing. So pretty fascinating. This is what they look like. I should have zoomed in here, but it's just this super clean etching, and it does micro etching. It also reveals the iron oxide, it seems, and then takes the rust off of it because it's just clean iron. And this photograph doesn't do it justice, but these are actually little sparkly metallic regions. Now, I'm again experimenting different angles. What does it look like from the top? And so I'm just trying different things and seeing how the RAV reacts. Look at that. It surely does like the top. I kind of felt like on the top I was really getting it. So I'm going to do a lot more practicing on the top. It also allows me to see where the tracing is, the etching is. Now I'm going to try in the center here because again, it's just another geometric shape. And what I'm trying to do, I did this with the two dabs on each side and nothing in the middle. I'm trying to figure out that is it the center that's all important, or is the RAV is it reacting in larger diameters? Can it? It kind of seems like it almost does here, but yeah, it really needs to have a flat piece of clay in order to build it. Look at there, I got one. That was it. And if you kind of think about it, this angle cut in the hole here was kind of flat, so it's perpendicular. So you need a semi-perpendicular, you need a solid surface in order to get what you're looking for. Let's see here. Wow, I can talk. We're going on 40 minutes here. There you go. Dialing it in. So here I tried a knitting needle because I wanted to see what would have reacted if I had thicker pieces. And what was interesting is that when it created a RAV, it seemed like it was thicker. Look at that. Look at how thick the stream is to the RAV. It definitely had a thicker stream leaving the electrode here than the other one. So I think that's because it has the larger surface. But that was fascinating. This is a solid steel bar. So this is many times thicker than the little steel wire that I was using. being a little repetitious here, but I know you guys, some of you are interested in doing this. So I'm hoping that this is helping you troubleshoot if you can't get it working, and to kind of further understand, because I'd love for you guys to do this on your own and then give me feedback on what you learned. Because look at this, it's just so beautiful. Look at that, just a spinning ball of plasma. And I have to say Vortex because it is touching the clay. This wasn't a very good one. You can already see it. A lot of noise. This was tougher to dial in, I think. But again, the plasma stream here to go to the RAB is thicker because it has, I guess, a thicker conductor, thicker anode. Okay, let's see here. Again, this gives the form that's indicative of a spinning top, if you will, and not an oscillation that goes back and forth. The cool thing too with this one was it was jumping and then coming back over here. So we have the flying RAV. I think I'm interested in the flying RAV the most, because then we're talking about a spinning ball of electrons basically rotating on the end of an anode. And so I guess the next step from there would be is to get the anode out of the picture and keep the spinning RAV. But yeah, that's probably somewhat impossible, but I'm not smart enough to know that I can't do it, so I'm going to try. So, okay, so this one's parallel to the clay, and I thought, okay, what is it going to look like? And it starts out promising, but what happens is, because it's parallel, it's going to start, oh, wait a minute, maybe this is not the parallel one. Looks like the parallel one. Let's just see it for a little bit. And okay, so it is the parallel one. So see how it starts stranding across the length here. This is why I wasn't able to really keep the beautiful RAV that I built earlier, because it just starts utilizing the length of the conductor here, and it doesn't have a focal point, though it started with one. And I think that has to do with the water. So what does the clay pot look like under the infrared? You can kind of see the rings now of heat that I tried to show you earlier when I took turned it off before it created the RAV, but that's sort of the heat dissipation. Now it's only showing 207 degrees. The clay is a really powerful insulator, and it cools very quickly, or should I say it resists heat quickly, excuse me. So it only has a very, very tiny spot that's hot. Maybe that, if that makes sense. I think I have another infrared here, but here I'm just trying to get them bigger and bigger, last longer and longer. And it's just a process. This one's a little bit closer than I usually do. But I love how it flashes. It's just amazing. And when it flashes like that, it's changing the frequency, but it's a clean frequency, like I showed you earlier, is just coming off of that. So here's what it looks like on the corner side, to see how the heat is transferring through the clay pot. So again, I'm probably also taking these videos after it's cooled for a while. My apologies. I'll get it fresh from a RAV, because I can already tell that these I had waited for some time. Okay, so now I'm gonna see if I can get RAVs and watch the oscilloscope. This was kind of me, what's the word, freestyling here, and just to kind of get you guys an idea. Now I put the oscilloscope so close that I don't even really need the oscilloscope probe, so don't do this at home. But one of the unique wave patterns was this one. I'm not sure what it means yet, but it's just fascinating that as it's clockwise turning, now you're seeing it get improved because I'm lessening the voltage. So the voltage is controlling the frequency of that noise. Now, if you guys remember earlier, I cleared up the noise, but I don't think I'm clearing up the noise here. But I think it's just worth showing what does the oscope do when you are getting these guys to run? And see what it does. I'm gonna see if we can clean this thing up. This is fascinating me too. You can hear a hush, and the plasma is not there, but it was creating a frequency. So interestingly, before you see light, spinning light, you have a spinning frequency. So also to see how all of the open of my 4-channel oscope here, all the opening probes are all turning on because the oscope's way too close. But you can see now that this RAV is organizing a clean voltage, and I'm here trying to just touch the oscope enough to where you can see it. Look at that. There's that sawtooth, or not sawtooth, but that triangular wave I was telling you guys about. And so it's just a fascinating thing. If this is not self-organizing, then the only way else I can prove it is if I have a high-speed camera. And yeah, that's out of my budget. Yeah, to catch this, I would need it in the thousands of frames per second, and yeah, they're a little outrageous in price. Um, and so look at that. When it goes quiet, you get this sort of somber frequency connection there without hardly any noise. And then there's the RAV. It's just smooths out again, and kind of trying to just show you how the wave patterns change. And so I do this a bunch of times because it's hard to capture all the different aspects of what this thing's doing. So here I've changed the vertical to kind of see if we can get some wave pattern. This kind of looks like a noisy resonant ring from a Tesla coil, and that's just because this plasma is rotating, and again it's in that clockwise manner. And I don't really try to adjust anything because I kind of just want to see when I don't have a RAV. This is what I'm facing. Ooh, get the RAV. Ah, and now it's noise again. So there's resonant rings in there. And you guys got to remember the input's DC. So all this voltage stuff is coming from the clay and the water, and that's it. And you're getting frequency. So here I'm just adjusting. There's the RAV right there. Oh, it's gone. There's a RAV. I'm keeping it. Notice how it's the frequency is increasing as I lower the voltage. So remember that opposite, lower the voltage, increase in frequency. This one's not the beautiful triangular wave, but still a frequency. It's a regular frequency too, so it's not just noise. Here I try to connect the coil to the oscope probe. So now I was hoping to see what kind of voltages can be induced into the coil. And it was underwhelming, I guess. It definitely has less noise. So the coil seems to be resisting noise. It's sort of smoothing out the noise. So I do notice that. But other than that, I think I get a RAV here. So let's see. There we go. So there's not really a big difference. Oh, here I'm trying to fix the wave. I don't realize I'm blocking it until later. So sorry about that. See, I do it again. So it seems like the coil, again, just takes away the spikes. And it's because it's picking up the electromagnetic radiation of this spinning plasma. So I don't know. I'll do more tests with the ring. Sorry, the coil. Coil is just about 5-6 inches away from the plasma here. It's almost right near the end of the plate here, so it's not far away. Let's see again. We're gonna, yeah, that. So this is the coil again. Yeah, just sort of smooth things out. You don't get a lot of noise. This is a double RAV. Ah, you just missed it. So the awesome. Look at how clean that is. It's quiet. Yeah, I love it when it's just quiet. Now there's some singing coming, I think. And we're almost done, guys. I don't know what it is, but I always seem to be able to fill an hour of talking. Okay, so this is turned on, but it hasn't broken the air yet. This is the frequency that's right in between here. It's pretty fascinating. Now you might say, well, wait a minute. No, this is the frequency coming from the flyback. It's not coming from the flyback. The flyback waveform is completely different, and it's literally way lower than this. So yeah, no, this is coming from the emission of the RAV hitting the coil, and the coil's inputting to the oscope. That's what you're seeing here. So basically, the oscope is now just a coil. And again, I'm changing the voltage. It's a RAV, and it alters the frequency. Pretty interesting stuff. We're almost done. Oh, okay. Here's my setup in case you guys want to screenshot it. This is what it looks like with the coil. I'm going to be doing a lot more, but I didn't have a lot of time. I'm going to blame my electrets research on that. I didn't do any electrets this time because I wanted to keep it one topic. Now notice here, it just came to me, try saltwater. So this is saltwater. I mean, it's beautiful. You can't really catch it on the camera, but it's an orange. It's a solid orange. It's also super squirrely. I barely got that RAV out of it. It's so finicky. That was it. So salt is awesome. I'm gonna play more with it, play around more with it, and then I'll try different stuff because it's cool. Salt again, just love it. It's not really a RAV, but it kind of is. It doesn't have that scattered spinning circle of purple. It's just amazing, really beautiful, bigger too. The salt, it's just salt water I'm using, guys. Dab the salt water there, that's it, nothing fancy. Oh, I put salt water in the dish too. This is what it looked like on the right here. So if you look on the left, that's kind of a normal. And then you look on the right, this is the salt. I probably have to brush off the salt here to kind of see what the etching looks like. But it's definitely different. The etching is either shallower or the salt's filling it in. But it's definitely different, something to look into. Very fascinating. Not sure what this is. I think this is out of order. So my wife let me have this clay pot before I bought the flat square ones, and this has an uneven surface. And this shows you right here, you can't get a RAV on an uneven surface. I tried different surfaces and you just can't. But I wanted to kind of show you what it looks like. So when it looks like that, don't do it. Again, here's another try. Same thing. It's just, yeah. I thought it would be fun, and it's just not. And here it is again with the thinner wire. And oh, I'm trying to use the flat surface of the lip of this curved, but oh wait, I think this might be copper wire too. Yeah, this is copper wire. This is to show you why you can't use wire that isn't rigid, because it's just moving all over the place, and you'll never get a RAV. It has its own unique kind of flavor here, but you'll notice here once the camera focuses in, this is not a RAV, okay? I don't know what this is. This is the copper wire, and it's all over the place. So yeah, you need something rigid. Will this guy be ever over? Oh my goodness. See what this one does. This is fun, guys. I really feel like we're hanging out together. You're in my garage, and look at that. Wow. Now I'm showing off because it's just so good to dial it in. Incredible. Almost done. Let me see. Here we go. here. I think we got some. Okay. So if you guys remember at the beginning of both presentations, I said that my inspiration was R.A. Ford. This is the book that I finally got in. And it's interestingly is I built my experiment before the book came in just from memory, and we're very close. I do a whole lot that he doesn't do, but this guy's my inspiration. So homemade lightning. If you want a fringe science book where a guy picks out fringe patents and he either shows you how to build them or he shows you how others build them. So everything this guy does fringe is built and tested. So he has a counter gravitation pages that I sent to Ian, and it's no joke. There's counter gravitation working on metal spheres, and this book teaches you how to do that. This one, electrostatic motors. Brent Jarvis recommended this to me. Awesome. Again, a lot of fringy kind of inventions here. They're all buildable, they all work. And then on the bottom here, this is a little known book on everything about electrostatic fields. And I can't get through a page or two at a time because it's so full of good content. So the top two books, if you want to build fringe things, and if you want to know how the other fields work, not the AC, but the static and the DC, this is the book for you. So I thought I'd recommend that to you guys. And what am I doing here? I think I'm doing salt on the side here, just real quick to show you what salt looks like on the side. And yeah, it's so tough to get a RAV. I might have too much, what's the word? Wicking. The water I think is too high. But no purple. You're getting some of the clockwise. It feels hotter. Look at that. It's interesting how it just sort of cleans up the water. It's almost like a vacuum cleaner, and it's sucking up all the water, stops and sucks it in. It's interesting that it's not as symmetrical as the other ones. All the other ones are circles. This one's kind of getting oval. It's sort of just licking up the water. So I like this. It's pretty interesting. And I think, see here, here's it again. It kind of has its own waveform. It's I love it. It's really cool. I'm also pretty far away, maybe a half inch, maybe a little bit more. But the RAV still has a pretty cool, clean signal. Yeah, there we go. Look at that. You can see a little bit of that salt still, keeping it orange. Not as much salt, I think, in this dab because there's some purple. When I really dab the salt, it's just all orange. So let's see. Oh, so this is the salt. When I really got the RAV formed for the salt, this is the wave shape. I've never seen a wave shape like this before. When the salt begins to spin up and it starts hitting its RAV state, it just sort of steps down and then comes up to its RAV state and then just kind of steps down. And the frequency is really low, 21 kilohertz. This is actually lower than any frequency that I've worked with. I think the power supply is 50 kilohertz. We were working in the hundreds of kilohertz. Here we have 21 kilohertz for this stair stepper. And so this got me so excited. I literally took this video right before we had this live stream. So I got excited about it. Don't know a whole lot about it yet because I didn't analyze it, but that pretty much sums up my presentation. Thank you guys for listening. I appreciate all of you. And let me see if I can stop presenting here. Go.
That was really cool, Shawn. Hey, did you see the purple inside the purple? Those two circles?
I didn't.
So when you have it going against a clay pot, you had a circle that was well defined on the inside, and then the outside, you had a hazy circle building around it.
I didn't see it. See, this is why I love you guys sharing this with me, because you see things that I don't see. Yeah. Okay. So now I have to look for that. So what are your thoughts? Like, what do you feel like you got a little bit better understanding of these little guys?
Oh yeah. Yeah. Definitely. It's so cool to see them get bigger. It's cooler to see the waveform change as you put in the salt. That was
Yeah.
neat to see. Yeah.
And what do you think of the phenomenon about to sustain it? Thank you, Tim. To sustain it, thank you, Vortex, Warcraft. Of as I go from 30,000 volts to 5,000 volts and it sustains, does that sound like you would? I would think more power would keep it going, or at least in that range. But no, it's like putting your foot on the gas and then coasting.
Well, you you're getting it to resonate probably, and when it does that, like that's why I said there was two fields of plasma. You're
Oh,
probably getting some kind of resonance in there. That way you can turn down the energy amount. It seems
oh,
like you're near a higher amount, but as soon as you get to resonance, you have to turn it down.
that makes sense. Oh my goodness, it was right in front of me. Yeah. Once you get flywheel moving, you don't need the same amount of energy to keep it moving. Oh, that's brilliant. All right, we're getting all kinds of comments here. Now I feel I need to fry some clay pots. All right, Darren.
I think we all need to fry some clay pots. Shawn, I got some behind me, buddy. I'm
I,
gonna be frying them when I get a chance.
I spent extra time on how to make sure and troubleshoot them. So I hope that helps because you have to have the right environment. You can spend all day pulling your hair out if you don't get that just so. So I hope you got it. Warcraft says Paul has two questions. So where are your questions, Paul?
Oh, Paul was asking this right here. Question 1. What's your favorite topic? Shawn is good. Solid state gravity coils. What's yours?
What is your favorite topic? Shawn is good. Favorite? Is he saying my topics are favorite?
He's asking in general, the whole chat, what's your favorite topic?
Oh, that's a good question. So, um, if someone were to ask me what is my passion in this, I would say resonance and fields. That's it. Resonant fields. If you wanted a third thing, I might say particles, or just electrons and protons. I haven't even really that much interested in light, but I might. But if someone were to say, "Hey, what do you love the most?" I love resonance. I love fields. And if you guys have seen my other presentations, um, completely different fields from the Tesla coil. And I never really thought I would get this deep in DC fields, and I never thought DC fields can be so amazing. I just thought they would be, you drag your feet across the floor and shock your hand on the doorknob and go, ooh, hoo, hoo. I didn't think that they had this kind of, I don't know, abilities, so possibilities. So I hope I answered that question, Paul. John Bigham, you're right. The salt is more conductive, so maybe that's why they reacted so quickly. That's right. Let's see here. Hope I'm wearing eye protection, Dennis. Thank you. Yep, all the time. Free energy unlocked in plasma, Elijah. Yeah. It seems like it's in that area. Darren says oscillating the salt crystals. Yeah, that's one to think about.
Yeah, maybe.
Yeah, maybe there's some vortex shapes in the crystals that I haven't on the deposits that I just haven't looked at yet. John Bigham says, Shawn, have you seen the portals you can create with this energy in a circular magnet, like a speaker magnet, donut shaped? So that's interesting because that was, you get a ring magnet off a batter, or I'm sorry, an old speaker, and then you put a rod in the middle and you run high voltage, and it has that clockwork action. It will spin, and it looks just like what's happening on the surface of the clay. But it kind of makes sense with a magnet. It doesn't kind of make sense on a wet clay pot. Not yet. So, but good eye. There's definitely a correlation somewhere.
Probably because your negative is magnetic.
I'm gonna put some gum in my mouth, guys. My mouth is just too dry, so excuse
I'm
me.
wondering if it's starting to lower the frequency in your positive and it's raising up your frequency in your negative.
Hmm.
You know what I mean? Because they're both out of resonance to each other. Maybe they're hitting a spot where maybe it's a half wave or something like that, where there's some kind of harmonic that pulls off in there, and that's what's giving you your lower state in resonance.
That's causing that spin.
Yeah.
Yeah, there has to be some nonlinear action at a right gradient that's causing it like a spinning top to just boom start spinning. And that makes sense. Maybe there are different frequencies. William says this is gonna make the best lasers.
Hmm.
Interesting. Thank you, Jar Jar. Yanni says, Paul, not sure of the question. I'm sure we can sort it out. Good luck. Straight dope, yo-yo. Yeah, I can't recommend enough Joe and Nathan's presentation that they gave. Was it last Friday?
We did it. Yeah, Friday.
Last Friday, Joe and Nathan take apart my RAVs, or our RAVs. They're not my RAVs, our RAVs.
Well, so far they're only yours. We're getting there.
Tim says, thanks, Shawn. Thank you, Tim. John says, one I think was from the water electrolyzing. Like as in an electrolytic capacitor, or that's an interesting, I didn't think about it that way. There seemed to be some capacitive reaction because the frequency changes with voltage, and capacitors are creatures of voltage. So because there's no coil, so there's no magnetic waves changing the frequency, so it has to be capacitance. So there might be a correlation between those aluminum capacitors.
Well, you are picking up two frequencies, though, right?
So there's a frequency that is on the flyback. That's an oscillator, and I had to isolate that to make sure it wasn't coming up. The frequency, there's not two types of frequencies. There's just a frequency that either changes as it's jumping around the clay and water, or there's a frequency that changes when I change the voltage. So I'm not sure where the two frequencies are in.
Because I'm seeing two frequencies on your oscilloscope at times in the thing. That's what's going on here.
I see. It's actually a handful. Yeah, it's a handful.
Yeah, so I don't know how to pull that out. You probably need two probes to put it on there to see if they're, you know what I mean, two distinct frequencies going on.
I'll have to think on that one because I didn't see it, but I can see it now because I've been staring at them so long. You're right. There's two different, there's a spinning donut within a spinning donut.
Yeah, that's what I was trying to say. With the purple too, you could clearly see it. If you bring up one of those, or later on we'll look at it, there's clearly two spheres in there.
Yeah, I can see that now. Before it turns into a RAV.
Yeah, right before it does too. Yeah.
Guys, I can't keep up with your comments. I'm sorry. Let's see. William Schwantz says a basketball spinning on a finger isn't resonating with the finger. I don't think you could have the RAV if you didn't have resonance. I don't think you could. And that proves it because before it turns into RAV, it has this kind of chaotic action, which is the multiple frequencies that you saw, Nathan. But when it hits to that one spot, yeah. In my research, it all says it's resonant. That's why I included it in the name. But it's an interesting point you make, though.
Well, if it was just one ball spinning, it wouldn't be resonant. He's right in that evaluation, but we are seeing two. That's what we're getting to in here. we're seeing 2 and it's showing up on the oscilloscope as 2.
Mm-hmm.
And that's what we're trying to evaluate in it. But one spinning ball is absolutely right. It wouldn't do anything.
Hmm. Let's see here. Good points. Banter, friendly banter. Sometimes it gets a little edgy in the chat. Some people like to come in and cut like a knife.
Oh, yeah. They come in hot, don't they?
Come in like a knife. Oof. That's fine. I got thick skin. Let's see. Wrap one tornado over another and you get a plasmoid. The saltwater RAV was showing light at an angle. That means it was lasing light. That's an interesting point. It really is. It was really bright, super
Oh, it
bright.
was.
It was a pure frequency of light too. It didn't have that super flicker. Interesting. My mouse is acting up, so I'm going from the top comments.
We keep getting this and you keep saying the same thing. That's what we're trying to say. There's 2 sides of his flyback. There's the side that's in the water. That's the negative. And then there's the side that's in the positive. You know what I mean? And between the 2, they're creating 2 different spheres on this surface. And you can clearly see them both. And you see them showing up on the oscilloscope. That's what we're saying. There's possibly 2 in there. So in between those 2, they don't have to hit exact resonance. They just have to hit, halfway of it or something like that in order for it to work together. So that's exactly what we're trying to say.
So I I have a little bit different color to add to that.
Go for it.
So when you see a noise, a static noise, what you see when it first is initiated, and then the frequency is low and it's mixed. But when it hits the right, I'll just say temperature, pressure, material in the clay. There's one more. The geometry of the anode. You reach its least labored. Oh my goodness, the least bound state. So it's the state of all hindrances removed to the maximum. So you start out with hindrances, and then you end up with the least hindered object, which just happens to be a spinning plasma sphere. So I'm not good with words right now, but if someone were to ask me what's resonance, I'd always say the state in which it's least bound, or the state when it's least restricted, or the perfect state of where there's no obstacles to it.
Mm-hmm.
And maybe it's a resonance is its purest form. Maybe I'm getting a little too esoteric, but resonating with what? Plasma's resonating with a piece of clay and dipped in water. That's what it's resonating.
Oh, I want to say thank you to ADX. Thank you, brother. I appreciate that, man.
Wow.
Taking care of me again.
ADX, you're amazing. I really appreciate that. I hope I didn't put you to sleep. So.
Oh, definitely not, man. Nobody falls asleep during your presentation, man. Everybody loves it.
I appreciate that. Thank you. I was going to say, though, if they bore you, you can use them to treat your insomnia. See, I have to say, people, what Shawn and us right now, we are going to blow your effing mind on Friday. Oh, this is Joe.
Yeah, Joe's working on something special over there.
What? Yeah, awesome.
He's got some numbers going, man, and he's got some, how do I say this? I want to call them fractals, but they're more than that. He's got ratios going, and he's figured out some cool stuff. So I'll let him break the news, but
awesome.
Yeah, it's kind of one of those things, Shawn. I have to go back and read it again myself because I was like half asleep when I read it today.
Wow. Awesome, Joe. Can't wait. Yeah, Vorcraft. There does seem to be a troll here. Yeah, you always have to have that detractor especially you always have detractors when you're onto something big. So
Oh, just so you guys know, a simple man in the chat, he only does it to get a rise out of you. Okay. He
yeah,
doesn't mean anything negative against the show, and he doesn't, you know what I mean, do anything like that. He's just trying to get a rise out of you. He's been here doing it forever. He says whatever outrageous thing comes in his mind, and he puts it out there. It
yeah,
makes me laugh sometimes, man.
yeah. It's funny. I think he called Vorcraft Vorfart, so I knew there was a little trolling going on there.
Oh, him and Vorkopf were going at it earlier, man. They
Yeah,
were into some yellow snow and some rocky road that wasn't so savory. But it was funny.
Stephen Schenkel says yellow in the salt plasma was probably the sodium lines. Interesting.
Oh, that's something to think about right there, huh?
Yeah, that is. All right. Reminds me of making a sodium lamp out of a pickle, Steve Schenkel. You know what? I didn't notice that, but I have a salt light, a salt lamp, and you're right, it does have the same hue. So
Hmm.
thank you for bringing that out. I'm gonna have to compare those. Thank you. Thank you, Ulysses. Super awesome, Joe. Oh, Joe, not me. Okay, never mind. Warcraft booted him. All right. William says,
No, you don't have to boot him, Warcraft. I'll tell you that right now. Just leave him alone next
yeah,
time.
yeah. I'll jump off
He's
that.
harmless.
Yep. Too much fun and good news.
Not like some of the other trolls I get in the morning.
Um,
Oh, William. Thank you, William, brother.
you're awesome, William.
Awesome. Thank you, man. Yeah, it's all Shawn doing all the hard work, doing the heavy lifting.
Oh my, please. It's so much effort to create this awesome community you've created. So huge kudos to our captain, Captain OMB. Yanni says the orange light may be sodium cool as cheers. So it is strange, yeah, that
Brenda was trolling me earlier. Sorry.
oh, okay. Thank you, Dennis. Love my high voltage power supply. Oh, a link for the high voltage power supply. Can I send that to you?
Now you can send it to Facebook if you want, and I'll put it on there.
Send it to Facebook. I'm just gonna take a note here so I don't forget.
Or you can put it in the private chat on here, and I'll take care of it.
You know, I sent the link to you.
I know it's so far buried in between the chat that we have.
Yeah, I'll just put a big star on this here so I don't forget. Yeah, all right.
I have to scroll through so much to look up things.
No sweat. No, you're captaining a big ship. So Dennis, I'll get the link to Nathan. Nathan will post it on Facebook.
Oh no! If you send me the link real quick on the Facebook to my Facebook thing, I'll post it right now.
Oh, do you want to take over for a little bit? I'll go get it real quick.
Yeah, you can put it in the private chat. You can click private chat on the right, and then just put it in there, and I'll post it.
All right. Do you mind taking the dialogue real quick while I go do that?
Oh yeah, go ahead.
Do this. All right, guys. You have our fearless leader.
Right on. Yeah, that power supply is awesome, man. So Shawn was telling me it's a real clean, easy running power supply too. And what did they do? They were pulling something static, the water and static out of the air in a device. Is that what it was used for?
Yeah, they're precipitators. So there's some interaction between the dew in the air, the condensation in the air, and electrostatic fields. I have tried every kind of power supply.
No, it's all right. I know I'm distracting you. You'll have to get into that a little bit because I think that's interesting to most people, just the topic of what they do.
Yeah. I'll talk about it here in a little bit. It's only showing up on eBay and
I,
AliExpress.
I think it was what, a couple $100 when you showed it to me last time and it went up
Under $100.
under
I found
$100.
Yeah, $90.
$90. That's a good price.
Yeah. All right. I found the link. Now this
Tim, I
one's
did get your
$60.
email on that. Yes.
Say again?
Oh, Tim asked a question if I got his email. Yes, I did.
Okay. I only use my iPad, so when I go on my PC, it's just batty.
He's getting it for you, Will. He's looking it up.
Yeah. Okay. You know how they cheat on the picture and on the item because they want to sell you a smaller one and acts like the big one?
Yes.
That's what. Okay. So I'm gonna try this. I'm super slow, guys.
It's all good, Shawn.
All right, sir. You want to try that? It's
Okay.
$60. So, I'm buying like 10 of them.
You're buying 10 of them?
Well, I've never seen them this cheap. I'm being facetious. I'll buy a couple more.
There you guys go. Right there. There's the link.
So, if I can share my screen real quick, I can show you the power supply and kind of
Yeah,
a
go
little bit
ahead.
about it and how to work it.
Absolutely.
All right. Let me know when. Can you see it on my screen?
Uh-huh.
Awesome. Okay.
Well, it's on Amazon too, huh?
Yeah, I made sure to find it on Amazon because it's easy for people. Um, AliExpress is a little, comes from a slow boat on China. And then eBay. You get a good deal on eBay, but not everybody does eBay. So Amazon's a safe place. This is super cheap. I can't believe I was paying $92. Here it's $59.99. But let me tell you how this operates. So these red wires here on the bottom, you have to make a plug like you'll plug into the wall. So you have to plug these into the wall, or if you have a what is it? An auto transformer or variac, you could use that too. But here's the thing about these power supplies: you can only put in the full voltage. You can't go 60 volts AC on your variac. What will happen is you could fry it, okay? So it needs a hard and fast. If it's 110, put it in 110, plug it in your wall. Here's something that I'm noticing uh, that is why this is so cheap. Do you see over here, it says AC 220 volts? Yeah, you see that, Nathan?
Not really, but we can understand it.
Okay, so when it says AC 220 volts, that's why it's cheaper. That means you need to buy a 30 volt step up transformer. So I can find that real quick here too. Let's see, it's a 220.
Real quick, while you're looking for that, ADX, thank you again, man. $3 again. Thank you, brother. Taking care of me today. Appreciate that.
Appreciate that too. Yeah, the generosity is so awesome. Let me find the cheapy one here. Here we go. You only need a cheapy one. You don't need anything fancy. So if you guys can see my screen, $26. You can even go down to this one, which is 18 bucks. I probably just stay in the 200 to 300 watt. And then if you buy that cheap $60, if you buy this, all you got to do is buy this, and then you plug it into the 220 slot here and plug this into your wall. And then boom, you have a high voltage electrostatic power supply. It's so durable that in the literature, it says in the manual, it says that if you create an arc between the wires, that it's in the optimal state. So normally when you have an electrostatic power supply, it's basically it's no arcs, no sparks, and that's its optimal state. This one, it's optimal when you're firing off plasma off of it.
Okay,
So
they're begging for a link for the other one now.
begging. Okay, let me get that.
Yeah, drop that for me real quick.
Yeah, we'll do. Let's see here.
Yeah, they're ordering this stuff real time, man. They're on it, Shawn.
It's awesome. Okay, so I'll give you the last here little quick click on oops.
All right, guys, give me a second. Here it is. There you go.
Awesome, awesome. I don't know what I'm doing. I lost you. Okay. So can you see my screen again?
Yes, we're good.
Awesome. So then on the top here are, because this is called a 2-channel, you're going to get 3 wires. You're going to get a red one, a white one, and a, it should be black, but I don't see it. It might be 2 reds and a white. One of these is the ground or the negative side, and then the other 2 can be positive sides. One of the positive sides going to be 15,000 volts maximum. The other positive side, 30,000 volts maximum. I think it has to do with current. I think the lower channel gives you more current. But when you take just 2 of these wires, you'll go up to 30,000 volts, just like any power supply, except for, of course, and it's DC, it's going to be high voltage. Because it's 10 milliamps, which you can't really see here, actually it says 5 milliamps. So that's even better. It's in a range where, yeah, I mean, look, if you don't know what you're doing, do not touch any of this, because you can get maimed or killed. But if you're used to power supplies, this is like the easiest high voltage power supply to use. It's not super dangerous. I have a big one that's dangerous, but not this one. So, and that's pretty much it, guys. Oh, there's a little knob here, and you just adjust your voltage, 5,000 to 30,000 volts. That's what I'm turning on when I'm creating the RAVs for you guys. So I think that's it. You go back to you, sir, if I can find you. I cannot find you. Here you are. Let me stop sharing.
Oh,
There we go. Woo. Close up.
yeah, I got a step-up transformer, Shawn. I bought. The thing is as big as my head, dude. It's like this big.
I have a boat anchor. Yep.
That thing you showed on there is small in comparison, probably lighter too.
It is, and I bought the big one, being all afraid I wasn't going to have enough current to put through it, power. But then I looked; it was 10 milliamps, 5 milliamps, and I go, "Oh my goodness, I should have bought the little one." So I did buy the little one. I think I bought the 300 watt. 300 watts, probably the little one that I use. So yeah, that's it. A metal dish, a clay pot, water, a rigid piece of wire, the power supply, the step-up transformer, and there you go.
Nice.
Well, simple. Okay, well,
I think that's what everybody likes. It's a very good result, and it's in a very simple setup.
yeah, I'm like you. If it goes over 10 components, you lose me. I really, and simple's hard. So awesome. I can't wait to see what these guys come up with. I know that I'm still going to be at work making them bigger, and I'm looking at my vacuum chamber too. I want to see what they do in a vacuum. I think that would be really interesting. That would help narrow down what's it resonating on, and because it might be able to let us dissect the RAV in a vacuum. That's my guess.
Well, I'll just tell everybody out there, whoever puts this thing together and wants to build it, just next time we're on, just let me know that you did, and then we'll check out your channel. We'll put it up, and we'll show everybody your results and things like that. I only ask that you keep the background music out of it, because I have to mute it, and I love to hear high voltage. So,
Yeah.
if you don't mind, You know what I mean? We'll have no problem putting it up and showing everybody. That way we can all benefit from it.
Yeah, good call, man. Good call. All right, so any more questions? We got going in the chat. I did something wrong with my computer. Am I frozen?
No, you're here. You're good.
Okay. I'm not.
I'm reading the comments, trying to.
Oh, good. All right, I'm back again.
There you go. Give Shawn the RAV credit. Nice.
Thank you, sir. Look, I derived the idea from R.A. Ford, and I'm just taking it to a whole different level. 30 years ago, he didn't have the stuff we have today. So, rad ravs. Thank you, Jarvis. That's cool. Yeah, nobody likes Surf Burt but me. Poor, some people couldn't even say it, so I knew it was not a winner. Surf what?
Hey, you gotta throw it out there, man. See, you know what I mean?
Yeah.
I love it.
You can please, what did Abraham Lincoln say? You can please some of the people some of the time, but you can't please all the people all the time. Something like that. Oh, Paul likes Surf Burt. Paul,
There you go.
because you're on a whole intellectual level above us all, man. You're awesome. Donnie laughs. Yeah, I call it Surf Burt. Well, it was an acronym, which I won't share because we got to stay with Rav. Rav. I'm sorry I even said the other word. Rav would be neat to test on clay. Yeah, it would be. I did try some other surfaces. I tried mica, and mica didn't absorb any water, even though I thought because it was a raw piece, it seemed porous, but it's not porous. It's just sort of sheets of impervious rock. So there's no. So it failed.
You know what it reminds me of, Shawn, when you were doing some of the testing, it kind of reminds me of an EDM machine. And it's only because the actual clay itself is pulling in the water. Because in those machines, you're taking high voltage and you're putting the negative to the metal, and then you're just pitting it, right? You're pitting it until it drills down through it. And it kind of reminds me of that if it was a more focused thing. So if you could focus it like a laser, man, you could right through it.
Yeah. It's if you found a way to structure like perfect lines of water on the clay and then turned it on, it would micro etch the clay to a shape or how you wanted it. Now I have an idea. I always get ideas when I talk to you. Because maybe if I can get the Rab to jump, it might be able to have an artistic aspect to it, like make a face or something out of water.
Well, because you got to think about it, and I always think about it like this: when you deal with granite, it works in the same way as the clay, so it's pulling up the water into it.
Yeah.
And you're creating an energy source from the negative, right?
Mm-hmm.
And then your positive is pitting it. So I look at it like this: if they had any kind of wire that cut the granite,
yeah,
then as you activate power into that through the negative part into the water, you're putting power in it. So now when you're sitting there and you're running your wire across it, you're not only getting the sparks that would originally create when it's dry, you're now getting it to react to the sparks that are going on in the negative of the water. So you're going to cut twice as fast.
Yeah.
But if you're pitting and stuff, then you get back to ancient Egypt and you go, well, how did they make these things so square and straight? It's the pitting. If their energy source goes through the water, then the source on the outside is the pitting. It's how deep do you want to go with it, then move it, and then how deep do you
precision etching.
Yes.
It's like laser cutting, but very simplistic. No circuits. Well, okay, the high voltage power supply, but I mean, there's ways to get very simple high voltage.
It's just an interesting way to look at it, and it'd be neat if you had a piece of granite, like in the junk pile, or you ran across one at the your favorite thrift store, and then
Yeah, I'll
it'd
look
be,
for
it'd
granted.
be interesting to see if it pits that way. I'll see if I got a piece myself, because I've always thought that with the EDM machine, and there's got to be a massive correlation there, and I bet you we could show it.
Just remember that the granite has to be a smooth surface. I didn't know they were porous. Um, but can granite soak up water if it's polished?
I don't think it has to be a smooth surface. I'll be honest with you. I think it's going to drive right through it.
I mean, I can't wait to see you do it. I can't wait till you have your video of the RAV.
Well,
I
it's not long. I put out everything on the counter, and I'm like, well, I got it. You know what I mean? I got my high voltage power source ready, everything.
Yeah,
I just haven't had the time to do it. And then when I go to do it, I don't want to be exhausted because we're playing with water and high voltage. So I wanted to
yeah.
make sure I was at least awake, because it's going to wake me up if I don't.
It'll wake you up the wrong way. Yeah.
Yeah.
Oh, it'll bite you. I've been bit. I've been bit a few times. I have rubber mats on the ground, so that helps. I wear rubber slides, that helps. I use one hand, but there's that time where I became part of the circuit and ooh, it wasn't good.
Hmm.
So Kristen Birkeland did experiments with a huge vacuum chamber and a central electrode like the sun.
That sounds interesting.
Doesn't it? I mean, I think it's going to grow like the sun in a vacuum chamber as well. That's what my guess is. So, great minds think alike, like John. Good idea. Dang, I'm late. A lot to rewind. Cheers, guys. Oxygen. Welcome, Oxygen. Good to see you. Better late than never. Lot to see, though. I'd love to hear what you think later. Mama,
Monolithic symmetry structures. Absolutely.
hmm,
We're getting into that. We're proving out something, but it's going to prove something out backwards in time if we're not careful. You know what I mean?
yeah,
Because you're starting to reveal what's going on here.
I love it.
It's like focusing light on a rock. You don't think it's going to do anything until the rock melts. And then right in front of your eyes, here it goes and melts and goes right into the shape that you wanted it in. And
Yeah,
you don't have to focus that beam of light over the whole thing. You only had to do the edges. And then
right.
you can make these two structures go completely flat to one another. It's crazy how this stuff works. And I guess I watched too many videos, because I've seen everybody, you know what I mean, working on this kind of stuff and taking different angles.
Yeah, yeah. I'm blown away at this little simple discovery. There's a lot in it, I feel like. I feel like there's a lot more than I'm seeing.
Oh yeah. So there's gonna be more.
Dennis says have a foot switch and important for high voltage testing. You place it 6 feet away from your project so you can't touch the project while it's on. My phone was 1 inch away from the arc to get you guys those shots. I mean, how close? How else do you get close to plasma like that? I mean, all you have is a phone. You can't
No,
zoom in. You got to
I
get
I
in.
use the camera with the zoom. I got to get a zoom lens bigger though, so I can
Mhm.
go further. But I love the zoom on the my other camera, man. It's
Yeah,
it changes the color too. The color comes out so much better.
it does. It does. I got to give my iPhone credit though. I mean, it nails some of the videos of the plasma. It really shows. For a phone, it's not bad. But I need a camera. I know.
I can't use mine anymore. It flips. It flips. I got too much high voltage next to it. It
I,
does not like the fields I create.
that's, I'm surprised mine's not joined you yet. Oh my goodness. That's terrible.
So Ulysses was asking how far does technology go back thousands of years? As far as what I've seen, over 20,000 years. Okay. So 2022, somewhere in there. It goes right back before the Younger Dryas. And from having Liz on the show, she was talking about that they were living through the times right before all this freeze over happened. So
Yeah.
pretty interesting, man. I think that we go a lot further back than what people would give it credit for. And to be very honest with you, man, I think that the Egyptian culture was what they knew in science was appropriated. They took it from somebody else. They assumed it
Mm.
once everything was done with the flood.
Mm-hmm.
So I don't think that they built that stuff. I think it was further back.
Mm.
That's just my opinion, though.
Yeah. William, 300 watts or greater. That's what I would go with. He's asking what wattage. Yeah. In every culture, doesn't matter, Native American, Babylonian, anywhere, they all have a story, a myth story of the earth being flooded, and that there was a boat, and that there was a few people on the boat, and that it's amazing how every culture has that in their mythology, which means mythology always starts with truth. In fact, sometimes mythology magnifies the truth.
Mm-hmm.
So yeah, oh yeah, there was a flood.
Well, they were finding layers in the soil itself that
Right.
showed an ash layer in there. So some kind of an impact and stuff. You know what I mean? In this stuff, I guess I ought to say they already found it. They know it's there. You know what I mean?
Yeah.
We all know the Younger Dryas happened. We all understand that there's layers in there. What they have trouble accounting for is and I forget the name of it. That there's a special layer that goes in there when it comes to meteorites hitting the planet,
Mm-hmm.
and that's what they can't account for.
Mm.
So I'm sure somebody in the chat knows what it was.
Hmm. Yanni's in Australia. Australian dream time is same fascinating, and the light rainbow serpent.
Nice.
Wow. Welcome, Yanni. I hope you're not yawning. Oh, that was so bad. That was horrible. I am horrible at jokes. See, this energy does not look like it's normal. A ground makes you wholly conductive to it, and oh, okay, they're talking about safety. See, Darren says we have the Seven Sisters story. I know, horrible, Darren. Thank you. Dad joke. So they're debating on wrist straps or no wrist straps. What are your thoughts, Nathan?
On which one?
Wrist straps or no wrist straps for safety? What is your opinion, Nathan?
Apparently, never watched my videos. I never used that.
Here's my wrist strap.
Yeah. You keep one hand behind your back and pray for the good stuff.
Lick your finger, put your other hand behind your back and touch it. And if you don't, char the end of your finger, then you're good. It's if you pull back a burning hot dog, yeah, that's your finger.
I don't wear any wrist strap, guys. I'm sorry, I don't. Like Shawn, I started to put the rubberized mat down when I do my voltage experiments.
Yep.
And I gotta order a bigger one for my table over here. Is what I'm looking at. But yeah, I put a black one down and it works great. And the zaps are gonna happen. I've gotten them full force with both sides, and that was a wake up call. And I've gotten them with one arm. So and then I get them when you go buy this thing. So my garage is like the central area for all my stuff. So I've been junking stuff, right? Getting rid of it and getting rid of it. But it wasn't always that way. So as soon as you go around the corner and, I try to be skinny going around the corner, but it never works. And so I bump everything, right? Let's just say that I got a shot in the groin from one of these things more than once by trying to get skinny through the area. Yeah. It literally lit up the boys, and Yeah, that
You-
wasn't feeling good for a while. I was
well,
rethinking my life after that.
well, Jarvis says here you need a groin strap
Yeah,
connected to ground.
yeah, I'm sure you do.
I would never wear any wire on my area and work on high voltage. No.
Yeah, I'll be honest with you, man. If it's got too many amps in it, I won't use the high voltage.
And that's the key.
Yeah, if it's got too much of a mix in there, I will stay completely away from it. Put on some gloves, and then really get out some different equipment to use it. Some really well insulated tools.
Yeah.
I won't come around it. If you know that you have super high voltage and super milliamps, you know what I mean, in it, that I don't mind. You know what I mean? We'll just wake up, but you get some massive amps in this thing. You start playing with AC from the wall, things like that. Turn it off. Don't even mess around with it.
Yeah. The Navy teaches for safety 30 volts, 30 milliamps. Anything above those, you have to take some kind of precaution. I would say these precipitator power supplies, they have 5 to 10 milliamps. That I wouldn't go higher than that. If you had like 20 milliamps, I'd be like, yeah, you're gonna add a layer. 30 milliamps, you're starting to get into the current of neon sign transformers, and neon signs transformers are deadly. So that's why 10 milliamps and below, it's really, I'm not going to say anything safe, but I don't wear gloves. I use one hand. Sometimes my hand doesn't thank me because I get shocked with it, but yeah,
Well, I'll
it's
be honest with you. When it comes to like microwave transformers that you pull
Ooh,
out of those microwaves, I
deadly.
always run a safety switch and I always run something over top of them. You know what I mean? Whether it's a
Yeah,
plastic bucket or something, or
yeah,
give me a tub, anything to keep distance between me and it, because they hold charge after you turn it off and they get you. And I
yeah.
don't like the way they get you.
It's the magnetic field. When you turn off the power, it collapses and it forces that last voltage right onto you, that
Yeah.
last current. So it's, yeah, and it's like 2000. No, it's like 4,000 volts, and the current is, yeah, it's
Yeah, those
dead.
things are lethal.
Yeah, I have like 20 of them because I collect microwave ovens, and I don't know why, but I feel like when the government fails in the apocalypse, I feel like those transformers are going to come in handy, and I don't know why yet.
Mm.
They're going to like
Well,
power our vehicles or something.
I got something for you. When you go and you get your next microwave and you want to do an experiment in it, you take your cell phone, an old one, and what you do is you just tap a hole into it. Okay, no, about a quarter inch or so, just enough for your camera to get there. You align your camera to it, and then tape that thing to the back of the microwave. Okay, now you can see everything inside the microwave as
Oh
it goes.
yeah, yeah.
So we
That's
saw a
awesome.
very cool experiment from a guy that's on YouTube. He took a beaker and he put strips of aluminum foil in the bottom, right?
Yeah,
And as it rotates, it creates plasma. It'll automatically hit plasma and then jump up to the top of that beaker and stay there. It's
it's amazing.
beautiful to look at.
It's deadly. It's
Yeah.
such a microwaves and the voltage in the transformer both to kill you.
Yeah.
It's beautiful though, super beautiful. See, I like safe. This is all safe. And by the way, I put safe in quotes because I don't want to be liable, but
Yeah.
I don't like messing with things that are gonna um you blink and you're dead. I can't. So that's why my Tesla coils fit on my desk. Okay, yeah, they can put out my biggest arcs are 18 inches, but it's a very efficient, self-contained plasma.
Mhm.
Mine don't radiate very well. Yours radiate well because your plasma is less contained. That's my theory. So when I have the ball, the Death Star, I feel like that the discharge of that plasma is more it's more balanced, so it doesn't have any energy to give out. Because the radiant energy of the Death Star was not very strong. In fact, it was very sweet, very weak at the equator.
Did you put DC into it, or were you just running the AC?
So I was running it off of ZVS, so oscillator at the resonant frequency of the Death Star and the capacitor I had with the ZVS.
And now I'm wondering, because DC from that Slayer might just make this thing, being a huge ball of thunder.
Oh,
Because it's different, because when you run the ZVS in there on DC, the
mhm.
field isn't as strong. It's not as big, but it's very precise. When you go into a Slayer, it just messes with everything in the room.
Because it's the best resonant frequency because it has a feedback loop. And it's how it always adjusts to its environment. It's always perfect. That's why it burns up. But you created the one that doesn't burn up, which is incredible.
Hmm.
Which is why I'm going to order one as soon as everybody's done cleaning out your what is it, stock. I don't want you to go out of stock in 5 minutes because I bought all your stuff.
I'm building up, man. I really
Yeah.
am. I've been relentless in it. It's like my days are filled with grandpa time on certain days. You know what I mean?
Yeah.
All day. And then building. And, I got a couple other projects on the side that I'm finishing out. But
Mm-hmm.
yeah, it's been relentless, man. Amazon loves me. Okay.
Wow.
They're like, oh, he's ordering how many of what again? Because you go in there and you go, all right, I ordered those coolers that go on your CPU.
Yeah.
And they get orders for like, hey, I need like 6 of them.
Oh,
And then
wow.
and then the next day I go, well, I need another 6 more. You know what I mean? And then, oh, by the way, I need like 20 orders of this. And it's like, what's going on with this guy?
They
So,
think you're a shipping and receiving at a company.
yeah. Yeah,
So
by the way, I agree with hold on real quick, I'll put this up. John, he was saying do not put them in a vacuum. Yeah, don't do it. Anybody who's ever played with high voltage knows you don't put it in a vacuum because you create X-rays.
Oh, with the RAV?
With high voltage.
So yeah, there's a big part of that that's true, and it just depends on the strength of them. And yeah, there's some of that safety in play. Thank you for bringing that up.
Yeah, they did videos on it, man, where a guy he got mad that he had to pay for X-rays and how much they cost, so he wanted to make his own machine. So he made his own machine. You just needed the X-ray bulb to do it, and then he put high voltage in there, not any more than what you're putting in your device now.
Yeah.
And he was getting X-rays out of it.
Mhm.
And yeah, it's completely unsafe to do at home. I would never do it. But then again, I do experiments to create X-rays when I do the bulbs and stuff like that.
Yeah, it's low doses.
Yeah, so
Low dose X-rays, I don't know if they have a big effect. I don't know. Paul says, Darren Henderson, can you give a quick moment for 2 questions? Okay, so who's Darren Henderson has 2 questions. Where are you, Darren?
oh, Darren's there. He said, yeah. He's just probably waiting for the questions. He's waiting for the questions.
Okay. It's a heat wave here, and I turn off my AC so it doesn't make a big noise. I'm melting.
No, just turn that thing back on. That's inhumane.
Yeah. I got this little
Oh, the fan?
For my AC, it's like 90 degrees in here.
Oh man, it's like 90 something degrees outside, man. You see right behind me up on the wall, I got my little mini split.
Wow.
That thing is amazing.
That's nice.
So it does heating in the winter and air conditioning, and
Those
for
are
my
nice.
garage, it worked out perfect.
What is it called? Mr. AC or something?
Mr. Cool?
Mr. Cool.
Yeah, it was a self-contained unit. So all of the, what do you want to call it? It's not antifreeze, but you know what I'm talking about. The coolant that goes in them is all contained in the lines. And as soon as you hook them up, then the seal's broken and it flows. So you don't need somebody to come install it for you. You could do it yourself.
Awesome.
So it was like a weekend project, man. It was like a couple hours done. You know what I mean?
Really good. What do they cost if you don't mind me asking?
It was a little over, like, I think $1,300 or $1,400
Oh, that's not bad. Not for
for
what
an
you
air.
get.
No, dude, for an air conditioning unit, it's great.
Cheap.
My daughter was like, Dad, why is that not in my room? You know what I mean? Like,
Mhm.
why can't I control my own air conditioning? Go, well, it's hecking here, man. It gets bad. Here in the garage, I got an insulated door, but it's still
Yeah. The
bad.
garage-
There's no carpeting, no flooring.
Right, right.
So
So Darren says Paul wants me to answer. Paul says, question 1, what's your favorite topic? Question 2, Nathan open to it that December take predictions and year later read them and ding if true or debunk if not. Is that what Art Bell did if not him? Sounds
yeah,
like
like Art Bell would see predictions and stuff like that. If there's any UFO disclosures, if there's something coming up, you know what I mean? What do we know in science? You know what I mean? Things like that, predictions that everybody has.
Hmm.
And then he's just looking to see what the topics are. I got a really, really cool neighbor.
Oh,
Yeah, I come over and talk to me every day, man. A
I
really
wish
cool neighbor.
I wish I had a cool neighbor. Everyone on my street doesn't speak English, and across the street they put up a foreign country's flag. I won't tell you which one.
Oh God.
So yeah, it's okay though. It's definitely a different country, and I live in Illinois. I have my cottage though too, and I can't complain. I mean, my wife and I have 7,500 square feet. It's nice. It's a lot of space.
Nice.
All right, so oxygen.
Oh, Mel's Hole. Art Bell and Mel's Hole. Dude, Mel's Hole is just funny because it's a hole. You know what I mean? Because it just they throw everything in there. Did you ever hear that story?
Mel's hole?
You throw your old couch in the hole. You throw everything in there as like a dump, and you could like turn on a light and throw it in the hole, and you'd never see the end of it at the bottom. And then weird stuff would happen in the hole. Like it would transform it into some kind of living being or something that you
Oh
could
my
get the
goodness.
rope down far enough. Dude,
Oh,
it was the greatest story, man. And then they found one on an Indian reservation that did the same thing. So
this a spoof or what is this? A movie? A show?
no, it was. You can watch it on the Y files. He did a thing on it. Art Bell did it back in the day as well.
Mel's
So
hole?
Mel's Hole.
Okay, I gotta write down. Because there is a hole in the ground of a farmer, I think is in Europe, and he's farming his land, and there's this 4 foot, 6 foot diameter hole. So he gets all upset and throws giant rocks in it. And for years, everybody threw their garbage in this neighbor's hole, never filled up. And then I want to say in the middle 1900s, like 1950s, 60s, they went in there in that hole, and it's a whole cave, and it's filled with water. It's one of the big underwater caves in the world. And when they dive into the water, they see piles of rocks and furniture, and they see all kinds of stuff down the hole. So that's what I thought of when you said Mel's hole, because neighbors would go and try to dump garbage in it, and they all scratch their heads going, why aren't we filling this hole? So yeah, I'm gonna Google Mel's hole because I have to.
Oh yeah, well just look up on YouTube the Y files, and
I'll
yeah,
do
he does a pretty good job, and it's funny, man. It cracks me up.
Sounds
I
good.
wish I could storytell like that as well, because that's amazing.
I I wish I could tell a good story. I love a good story.
Yeah.
I'm good at telling you what I think, though.
Yeah.
I'm good at sharing my opinion.
Yeah.
That's terrible.
Huh.
Oh my goodness. So now the chat is descending into the
Oh,
abyss of junior high bathroom humor.
everything's about the hole.
Uh, I'm surprised I didn't get it when I was moving the probe over the hole.
I was just with.
I didn't mean it how it came out. It just see, you can't even talk about it without laughing like a
Well,
kid.
think about it, Shawn. You got a very big freaking probe that you use for your stuff, and you're going, "Look at my
So
probe here." And, sorry, man.
it's
I crack up every time you put it on the screen.
oh my goodness.
Hey, you got to laugh at something in life, man, and it's harmless to laugh at that.
I I like this one video guy where he gives you like little snapshots of politicians contradicting themselves, and he does the farting sound when the politician talks. So there'll be blah 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 blah, and it makes me laugh. My wife's like, "What are you laughing at?" The fart noise. I am just so. It's funny. Why is it funny? It is awesome.
Oh man, yeah. One of our politicians from California was blasting gas on the news. Man, he let it rip. Man, he was on a live newscast and he just like super
What?
loud in the halls of Congress or something, or right outside of it. It was
Oh,
hilarious.
yeah. He was with Fang Fang,
Yeah,
the Chinese prostitute spy.
the
Oh
guy from
my goodness.
California.
And the in the echoing halls of Congress, it was amplified. And he's talking, and the room just, I mean, what? Barking spiders
Yeah,
everywhere.
he had
Barking
such a
spiders.
straight face. I'll give it to him. He had such a straight face when he did it. Like
Uh-huh.
he didn't give any indication, but you heard it.
But he had like a microsecond of he knew he did it. But only if you'd like watched him, you knew he did it, because you're right, he played it off perfectly. But there was this like flash of, oh no. What's his name? Jeffries? No.
Swallowswell. Swallowswell.
Swalwell.
Yeah.
Swalwell.
He's from California. I would call him
Yeah.
Swallowswell. He's a
Swalwell.
horrible politician.
He is not good. He is not good. He's as good as the methane that surrounds him. So oxygen says, what is a resonant arc vortex? So I'm only describing its action. What it is, electrons, waves, ionized particles, heat. Um, I mean, it's a good question. I mean, we could take it apart. 30,000 volts DC, 0.2 millimeter stainless steel rod, 4 millimeters away from a dampened piece of clay. Clay's semi-conductive. As it heats up, the resistance changes dynamically. That somehow causes the ionized gas to spin, the electrons spin. And you know it's in resonance because it becomes completely silent, self-contained. Yeah, that's what I feel like I'm observing. But honestly, ask any physicist, what is an electron? I don't know. They'll tell you it's mass and gravity and velocity and spin. I mean, it's a good question, Oxygen. I'm not trying to, say anything negative. It's a great question. We need to question everything. Trust no one. Question everything. Oh, thank you, Yanni.
Yeah. But you can only describe what you see and what you know is there, and then everybody can do their determination after that.
Right, right. And I keyed it into uh, heavily into Google white papers. I did AI, and I mean they all kind of sort of agree. So, and they don't speak fringe. Thank you, Jar Jar.
Hmm.
Um, Yeah. Oh, oxygen. Sure, you're welcome. Yeah, 4 millimeter gap. Yeah. Um, if it's too far, uh, it'll be all over the place. If it's too close, it's too pinpointed. It won't get the spin. It won't turn into a wrap. So, form basically a half a centimeter. Just start there, and you'll be able to move it back and forth as you get used to it. No worries, oxygen. No worries at all. Um, yeah, I hope you like what you see earlier in the video. Because there's some spinning plasma. I like to say self-organizing plasma because I didn't do anything. There's no mechanism that's spinning it. It's a reaction of things coming together,
Hmm.
and it's in a way where they want to spin, and yeah.
So funny because there's something going on that nobody really realizes and they don't pay attention to because we don't ever talk about it. But as you build out energy from something, you're not just building it out; it's being contained by something.
Yeah.
I mean, just think about this: the environment you're in is containing it. It's not allowing it to grow any bigger. If we were in a different gravity field, then the voltage itself would have grown out, twice, three times the size.
Mhm.
So it's always interesting to know that little simple fact that the environment itself's holding it in. If you can harness and focus the environment, you can hold it in.
Yeah, right.
Pretty interesting.
And when you look at the fusion, they're trying to create that cold fusion, because fission creates a lot of nuclear waste, but fusion does not create nuclear waste. Fission as a very pretty safe power source. Nuclear power plants use fission. If they can do fusion, it's more energy too. And one of the key components of fusion is you need to have to contain the plasma. You need to keep the plasma in one place. That's super complicated. And they have very complicated pieces of equipment to compress that plasma to a temperature that can achieve fusion because it's a temperature thing.
Mm.
Fusion happens all the time on the sun. Two hydrogen atoms fuse, they create a helium atom. That's what powers the sun, fusion. So, what fascinates me about the RAV is it is a kind of self organizing plasma. You see it, it's contained, it is hot. I mean, it's millions of degrees. And you know that because it's incinerating the clay. It doesn't even allow smoke. It literally makes the clay disappear. I mean, and the steam too. It's an invisible steam. You'll never see any visible steam come from it. So
Oh,
it's pretty hot.
I got something to show you, Shawn. Okay. Mission Control posted something. I'll see if I got it right here.
Okay.
So we got anode cathode, and then he's showing the saltwater moat making a particular shape. Did you see that shape in your thing that you're doing at all?
Um, it seems, I mean, it's a reach, but I thought I saw something like this in the salt when it was etched into the clay pot and it left the salt deposits. I felt like it looked kind of like that. I'll have to check it out.
Okay, hang on. So click and read more. Give me a second.
Oxygen is
Oh,
intelligence. Interesting.
he's got a whole thing going on here. Hold on. I'm gonna have to leave you this link, Shawn, because there's a lot to go through here.
Okay, yeah. Also, too, Nathan, I'm having a great time, but I need to take some medication here soon.
Oh
Um,
yeah, not a problem.
I'm
Sorry.
having a blast though. I wish I could stay longer. Guys, you are great. I really appreciate you guys all coming and listening to me jabber for wow, 2 hours and 10 minutes. Awesome, guys. You guys encourage me. You guys enrich me. You guys give me awesome ideas, and I appreciate hanging out with you guys. I hope to do this again next week. I haven't decided yet. Either I'm gonna have to spend some time with the electrics. If it's really hot though, thank you, Darren. Thank you, Dennis. I might put the RAV in a vacuum chamber. I just want to see what it'll do. I mean, my guess is it's gonna get big. It's gonna grow. Thanks, Paul. Thanks, Yanni. I really appreciate it, guys. You're too kind. All right, gentlemen, ladies, take care. Much love, and thank you, Nathan.
Thank you, Shawn. I really appreciate you coming and doing this, man.
Thank you so much. See you later.
All right, man. That's cool. Awesome job, Shawn. Awesome job, man. Love it. All right, man. Yeah, it's about time to take off. I just want to say Mission Control has posted some very cool stuff real quick. And here's the link for his channel. Look on his posts, and that's where you're going to find it. I'm going to have to look up what he just put out there as well. A lot of good information on there. So check it out, guys. All right, with that said, man, I want to thank everybody for hanging out with us today, man. It was totally awesome. Great show. Thank you, Shawn, for coming in and doing this, man. Thank everybody in the chat, man. I just want to, Shawn was a new member today, man. And then ADX, take care of me, man, twice. And then William, man, I hope you do good with the power supply and stuff. And thanks for taking care of me, man. I hope it works out and gives you everything that you were looking for in it. And that project goes well for you. So with that said, guys, have a great night, man. Thank you.
The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.